Alright, so in the previous videos that you've done about best fit models, you've done basically just finding the best fit models. So now we're going to learn how to actually use those best fit models to make predictions. So we're still going to be going through the process of how to put it in Desmos, but again, we're going to be using it for prediction purposes. So we have a table here and it compares the number of hours studied to a final exam. So just like you would have before, you're going to go to Desmos and you're going to put in your table of values. And once you put in those table of values, you're going to look at your scatter plot. And using that scatter plot, we are actually going to make some predictions. So that's what I'm doing right now, is putting in my best fit values. I'm going to make sure, see, I can already see that I made a mistake somewhere. So always go back and check your scatter plots and your tables. And just make sure, see, like right here I missed a 4. That one number could completely change what I'm putting in. So remember, there's that zoom button right here in the corner. So if I click that zoom button, it is automatically going to zoom for me. But I want the equation. So I'm going to do y1. My squiggle means similar. Then I have mx1 plus b, and I have to use y1 and x1 because of the fact that that's how my table is labeled at the top. Alright, so a couple of things that we're going to look at. So the first thing I'm going to look at is I'm going to look at my R value. So my R value tells me how good of a fit this problem is. So R equals 0.989. This is strong and positive. So we know when we make this prediction, it's going to be a really good prediction. So I'm going to look at my M and my B now. So my M, I have 6.08871, and my B is 63.9274. Now, I like to round 3 decimal places, so if I'm around 3 decimal places, I have to look at my fourth to determine if I round my third. So my fourth here is a 7. So that's going to round that 8 to a 9. So y equals 6.089x. So 3 decimal places here. I'm going to look at my 4 to determine if I round. So that 4 is going to cause that 7 to stay the same. So that's going to be 0.63927. So what is this saying? So this is saying, when I'm looking at this information, that I have a y-intercept of 63.92. So that means basically without studying, I could get somewhere around a 63, 64. And then for every hour that I study, my slope tells me that my score will go up by about 6 points. So now what they want us to do is they want us to make a prediction. They want us to predict what will my grade be if I study for 6 hours. So hours is going to be my X value. You need to make sure you are very careful about this when you're looking at whether to plug in for X or whether to plug in for Y. So I'm now going to take 6 and I'm going to plug it in the X spot. So this is going to be 6.089 times 6 plus 63.927. And I can plug that right into Desmos and I can get my value. And I got 100.461. Now, if we're thinking logically about this, and we're thinking about the fact that it doesn't say anything about extra credit or anything like that, my expected grade is really going to be 100. So they're saying that 6 hours is about the max you're going to want to study, and then your grade is not going to get any higher because you can only have a max grade of 100, which is why I asked you, can the line go on forever? And the answer is no. You can only get a max score of 100. Just some logical things to think about. All right, so let's look at this next example. So we're talking about the height and the shoe size. So again, we're going to put this into Desmos. You are more than welcome to just go and delete these items if you want to, or you can delete the whole thing, completely up to you how you want to do it, but just make sure your X1 and Y1 are there. So we have, and I'm going to continue on with my Y values. This is my shoe size that we're comparing now. So again, just take a quick glance over it, make sure it looks good. Hit your zoom button over there in that corner, and we can see that correlation there. Looks pretty linear, looks strong, but let's check it. So I have y1 squiggle, and I have mx1 plus b. Now again, if I'm looking at this, I have an R value of 0.997. This is going to be positive and strong. Okay? But more or less, we want to write our equation. So we have m equals 0.421132, and we have b equals negative 19.8127. So again, I want to round 3 decimal places. So there's my 3, but I'm going to look at my 4th decimal place to decide if I round my 3rd. So that 1 is going to keep that 3rd decimal place the same, minus, okay, because we have a negative, so we have 0.8127, and that 7 is going to round that 2 up to 3. So I have 19.813 is going to be my equation. Now, this is why right here I said you need to be very careful. It says if a man has a shoe size of 10.5. So my X was height, my shoe size was Y. So this time they gave me the Y value. So I'm going to have to take 10.5 and I'm going to have to plug in the Y spot this time instead of the X spot. So this is going to be 10.5 equals 0.421x minus 19.813. Now, what do I do with this one? This one's not as simple. I'm going to need to solve this equation. So as I'm solving this equation, I'm going to do it just like I would any other problem. I just need to be very careful because I have lots of decimals. So I'm going to do 10.5 plus 19.813. That gives me 30.313. And I have 0.421x, so I'm going to divide by that 0.421. And I get that x is approximately 72.002. So we'll just leave it 72.0. So if they're predicting that if you have a shoe size of 10.5, then you should have a height of 72 inches. Okay, so if they give you an x, all you're going to do is evaluate. You're going to multiply your slope and add or subtract your y-intercept. If they give you a y value, then you're going to have to actually solve that using your inverse operations. All right, so let's look at another example. All right, so if I'm looking at this example, it's already graphed for me. It says, how many dollars did Jim earn for working 5 hours? So the first thing I'm going to recognize is I have hours worked and dollars earned. So this is my X, this is my Y. So if I have working 5 hours, that's an X value. So if I go to 5, I can see that that correlates with approximately $48. All right, so then they ask us, predict how many dollars will Jim make for working 10 hours. So 10 hours, we'll go to that line of best fit. We can predict about $72. So we would be able to say that my slope is positive because it's going up. But if I'm looking at the next part, it says when Jim's hours increase by 5, how much do his earnings increase? So if I'm looking at how much his earnings are increased, so for every 5, how much is it increasing? So it's basically asking me for the rate of change. So if I'm looking for my rate of change, in this I have 2 points. I have 5 and 48, and I have 10 and 72. So I would do my rate of change. So 72 minus 48 over 10 minus 5. So if I go back and calculate this, I would have 72 minus 48 divided by 10 minus 5. So it approximately earns an extra $24 every 5 hours. Let's look at this example. I pulled this one directly from Desmos because I wanted to make sure that we were all clear about the rounding. So we have a newly reported crime case in a county in New York State. So it says X represents the number of years since 1997. So before, when in your last video, if they gave you the year, then you had to convert it into the number of years, but they've already converted it for you, okay? So they want you to write a linear regression. So linear regression just means line of best fit. And they want you to round your values to the nearest tenth. So this is different. I normally say round 3 decimal places, but this one says round to the nearest tenth. But after we do that, we want to predict the number of cases in 2005. And they want us to round that to the nearest whole number. All right, so the first thing I'm going to do is I'm going to go ahead and just put my table in so that when we get to our problem, we already have this ready to go. I have my table. I can hit my zoom fit. I can see it's a pretty good fit. So I'm going to do Y1 squiggle MX1 plus B. All right, so again, just a couple of things. My R value is 0.989, so this is going to be strong and positive. So this is a good fit. Now, it's said to write the equation. So I have an M. My M value is 23.3. And my y-intercept is going to be 921.8. Now, it says round to the nearest tenth. So when we talk about tenths, this is the tenth, this is the hundredth, and this is the thousandth. So when we talk about decimal places, tenth is the first place. So you really don't have to worry about rounding because it's already on the 10th decimal place. So we have y equals 23.3x plus 921.8. So we have our equation. Now they're asking us to find the number of cases in 2005. I'm not going to take 2005 and plug it in for X. We are not going to plug in 2005 because 2005 would represent 2005 years. We don't want 2005 years. We want 2005 minus 1997 because that's how many years we're actually talking about since we started calculating the number of crime cases, which is 8 years. So we're actually going to plug in 8 into the X spot because 8 is going to represent X years. So we're going to do 23.3 times 8 plus 921.8. Now this one says to round to the nearest whole number. So we have 1,108.2. So that 0.2 is going to cause that to remain 111 or 1,108 new cases. All right. All right, and the last one for this video. It says that a mathematics teacher, there's a correlation between the test and the homework. So X is going to represent the homework grade, Y is going to represent the test grade. So we're going to write a linear regression model. We're going to round to the nearest hundredth. So hundredth is going to be 2 decimal places. And then we're going to make a prediction that if my homework grade is 62, what is my test grade? So again, we're going to plug this right into Desmos. We're going to use our table. And once we do that, we're going to write our equation. And after we write the equation, we're going to plug in our values. We're either going to plug it in for X or we're going to plug it in for Y to make some predictions. Again, always be careful when you're plugging your numbers into Desmos. Just kind of make sure you glance back over them and you don't see any errors happening. Okay, so I'm just going to look back over my values, and I can see right there that I made a mistake. That should be 87. All right, I can hit my Zoom Fit button, and I can see that there is a good, strong relationship there. So we have Y1 squiggle MX1 plus B. And again, I have an R value that's 0.9746, so it is strong and positive. But more or less, what I'm more interested in is my M and my B. So this one says round to the nearest hundredth place. So if we're rounding to the nearest hundredth, we're rounding 2 decimal places. So I want to round to 2, so I'm going to look at my third to round my second one. And so I can look and see that for my M is going to be 0.49. That 1 is going to keep that 9 the same, minus 39.19, because that 5 is going to round that 8 up. So there's my best fit model rounded correctly. Now they want us to predict, find the test grade, the projected test grade to the nearest integer or nearest whole number. If my homework grade is 62, so homework is X. So we're going to take 62 and plug it into the X spot. So we have 1.49 times 62 minus 39.19. All right, and we get approximately 53.19, so we're going to round that to a test grade of a 53. So again, this is basically saying that if you don't do your homework, so 62 on your homework grade was not very good, so the more successful you are on your homework, the higher your test grade will be. So this one, they were not that successful at a 62, so their test grade was at a 53. All right, so with best fit models, make sure your rounding is correct. Make sure that when you are plugging it in, are you plugging in for X or are you plugging in for